Last week, we stopped there. Question: restaurant sell multiple products. They sandwich, drink, and baked potato. Then annual sales units 9,000, 9,000, 7,000. And price is $5 unit, $1.50, $2. And then cost is like a variable cost, $3, 50 cents, and $1. So multiple product break-even analysis. So using this formula, to get this formula, we need a certain calculation. So using a chart, we can calculate annual sales. And then we need fixed cost divided by sum of 1 minus variable cost divided by price. That is kind of margin. So margin, 1 minus margin, this is contribution to sales. And then times W, this one is kind of weight. Total sales, then what is the percentage of each product sales? That is the percentage of the sales. So using this table chart, we can get this one. That is this part. So this one is this part. So fixed cost divided by total weight contribution. That is the break-even point of total multiple product. So to calculate each number, we need the calculation. But if we use Excel and then build up a chart or table, then it's somewhat easy. So copy and so this file is on Moodle. So we wrote up this one. So this break-even point is this part. So before that, we need each number. So this one, this part. So variable cost divided by price. Variable cost divided by price. That is margin rate. So equals, type equals. So variable cost of this one. So click this cell and divided by, type divided by price, selling price. Enter. 0.6, about 60%. And then next one, you can type equal variable cost divided by price, or you already did this in cell, just copy like this. Then you can see D6 divided by C6. D6 D6 divided by C6, and the next one change D7 C7, and so on. And I like 3-digit decimal points. And contribution, that one is 1 minus this part, margin rate. So contribution rate equals 1 minus this part, enter, then again copy. Then annual forecasted sales, annual sales, that is, oh, this one supposed to be not dollar, that's supposed to be how many, so change. So 9,000 annual forecast sales units times selling price. So annual sales equals how many times selling price, enter, and then copy again. And then we need total, so equals sum of, you can type now sum of, or you can just click this one up there, type, and then if we find this one up here, then double click, and then specify, enter. So annual sales is 72,500, and then percentage of sales. So this one's percentage of to total. So equals this one divided by total. So we will use this total for every cell. So make it absolute value by typing F4. You may just this one divided by this one, enter, and the next one, this one equals this one divided by total, one by one. That case, you don't need to make it absolute value, but if you want just copy, then make it absolute value, because we will use this total cost for each cell. Enter, and then oops, not copy. Then as you can see, G9 no change, because we made this value as absolute value. And then this one total the same. This one should be general 1. And then I will make it 3 decimal points. Oops. And weighted contribution, that is column 6 and 8, so equals column 6 times column 8, enter, and then copy all the way down. This value not dollar, this one is general percentage, so oops, I like the 3 decimal point, and then this one, sum of. So this part is column 6, and then this part is column 8, and then sum of. So this part is this denominator, whole denominator. So we need sum of. We already sum over here, so just copy. So this part is 0.469. So this one, break-even point equals fixed cost. This one annual, and then monthly fixed cost. Go back to the question. So fixed cost for a month is $30,000. So annual cost is times 12. So this one will be 3,000 monthly and then 12 months. So we need monthly fixed cost times 12 months. So that is the total fixed cost. This upper part, numerator, and then divide by this part. This part is this one. So click this part equals $76,764.71. Here, annual sales is 72,500. But the break-even point, because of the high fixed cost, this break-even point is higher than that annual sales. So this question said this restaurant open 6 days per week, then 52 weeks. So open 312 days here. So open 312 days because open 6 days per week. So from the calculation, the break-even point per day will be equals the break-even point divided by 312 days open. So daily sales should be $246 or more to make it profit. So this case, we know break-even point and then annual sales expected. And then this one is daily sales. So if you, from this insight, you can decide, or you can do something like where you can save cost to make profit. So that case, maybe variable cost decrease, or fixed cost decrease, like that. So this is break-even point, break-even analysis, multi-product break-even analysis. I feel sorry, but you have an assignment. but I made the table, so I will open it. So looks like this. So follow the same process. Okay, and then one thing, this one is not annual. Actually, this one is not annual, monthly. This is month data. I will check. It's too many. 30,000. I will check, and then if it is not right, then I will change. So I made this. I will change this one months and so on. Then I will make sure this number right. So then just to follow, then this one total fixed cost is 3,800 only. So you don't need to calculate annual fixed cost. This one, just to use this fixed cost. I will check, and then I will revise and then upload this file again. Okay. Then next chapter is module A. Our textbook, the most, not most, some quantitative part placed the end of chapters. Then call a module. Actually, this one is like a quantitative module A, B, C, D, E. So first, quantitative module A about the decision making. Operations management, conceptually, I said many times, make it better, cheaper, faster. And then to make it better, faster, cheaper, managers always decide something. So operations management officers, managers should be decision maker. So many times make a decision. And then many cases from multiple options or multiple alternatives, we should find the optimal decision or solution. So one earlier example, break-even analysis. There are multiple options. Then from based on the demand less than, then A option, between demand, then B option and C option, and selected. So from multiple options, alternatives, we decide which one is optimal. So one of the decision-making method is a decision tree. So talk about this now. Fundamentals. So now decision-making terms, alternatives, and state of nature. If there are multiple options, then if we can choose, decide which one is better, that is alternative. But state of nature, we cannot choose based on a certain environment or probability chance. It move itself. So to use that decision tree, we use symbols like this. Square means symbols used in a decision tree, and then this one is decision point. This one is decision point. That is alternative. So we can choose using a certain condition or such as profit and so on. We can decide. So this square symbol in decision tree is this decision point. And then a circle, this node is a state of nature node, out of which one state of nature will occur. So decision tree looks like this. Decision point, and then if there are multiple options, 1, 2, 3, and so on. So using circle, and this point is the kind of expected in other textbook, and they said this point as an expected value point. So using nature, then like a probability or chance, then profit, and then get the expected value here, and then expected value for each alternative, and based on that expected value, decide. So in other name, this circle type node is expected value point, decision point. So using expected point value, decide which one is the best option. Decision-making environment, decision-making under uncertainty, under risk, under certainty. The nature usually uncertain, but sometimes we forecast using forecast method, then predict. So if we don't know anything, then that is under uncertainty. And then if we know something forecasting with a kind of probability, that is under risk. And then decision making under certain, if we know certain the results. So using that certain result, then decide, that is decision making under uncertainty. Here, decision making under uncertainty, then one of method, maximax among alternatives, then the highest expected value, taken the highest, that is maximax method. So find the alternative that maximize the maximum outcome for every alternative, and then pick the outcome with the maximum number, highest possible gain, take highest possible gain or outcome. This one is optimistic decision-making criteria. And next one, maximin. Among maximum outputs, of each alternative, take minimum, minimum. This one is minimum. That is actually this one is the minimum. Among them, this one is minimum the same. So maximix method, and then this one is the pessimistic decision-making criteria. It's like not to lose much. And the next one, equally likely. That means just based on their chance get the chance equally, then average is of this average outcome of this alternative is 10,000. This alternative average is 40,000, and do nothing is 0. Among them, biggest one take. That is equally likely decision-making criteria. And decision-making under risk, if we know forecasting and then with the kind of chance, percentage, probability, then using that probability, first option or alternative, expected value, expected monetary value, or just simply expected value. The chance of this one, 200,000 is 60%. So this outcome chance, this outcome and chance, and then add expected value of this. Now first alternative is 48,000. Second alternative, expected value is 0.6 times 100,000 plus 0.4 negative 20,000. So expected value of second alternative is 52,000. And the last one is 0. So among expected values, take the highest one, that is decision making under risk using EMV, expected monetary value, or just simply expected value. Usually in decision making, many cases we use this expected value to decide which one is the best alternative. And decision making under certainty, similar. This one is determine the expected value of the perfect information. We think it is not perfect information, certain information based on that. So expected value with perfect information will be EVPI will be expected value with perfect information minus maximum expected value, earlier this one. And then EVWPI, that is highest one among those favorable market value. It's kind of optimistic because now we know this is like a certain number. So based on certain value of each alternative, and then here maximum, 200,000 times 0.6, and then unfavorable among them maximum times 0.4. That is expected value with perfect information. EVWPI, that is 120,000 minus maximum EMB, expected monetary value. That was this one, minus, and then $68,000. Okay. Example. There are three alternatives. First one is move store to new location. Second one, expand store, existing store, and then do nothing. And then after 1 year, if strong growth, then decide again, expand or not expand. Then if the condition is not good, just to do nothing, like this, and then revenue, and so on. So, using this information, we can draw decision tree. Decision tree looks like a tree like this. So there are three alternatives, and then each alternative has chance, strong growth, weak growth, strong growth, weak growth. Then the last one, like this, do nothing, but later, if it is strong, if it is strong growth, then decide again. Weak growth, do nothing, like this. We can draw this decision tree using hand drawing or many program we can use. We can draw this decision tree using Excel and other programs, but I recommend one of the web-based program, that is silverdecisions.pl. So if you type this silverdecisions.pl on any web browser, then we can go there. Okay, if you can, do it together. So type silverdecisions.pl. When you're ready, then let me know. Then I will go with you.
I'm ready. Okay.
Ready.
I'm ready too.
Okay, good. So you can, you have this kind of menu, right? Okay, then just click run. Then it's like a blank board. Okay, we have 3 alternatives like this. And then by the way, we need decision point. So anywhere this the plus type cursor, right button, the mouse right button, then you can see, press U. We need a decision node. So click add decision node, then square. So starting point is like in a decision node. And then there are 3 alternatives. So on this decision node, right click again, right button again. Then we need chance node, that is alternatives. So click 1, and then again 2, again 3, because we have 3 alternatives. And then go back to this one, 3 alternatives, and then each alternatives has 2 chances. To nature chance, strong and weak growth. So go back to that one. On this first alternative node, right button, and then we need terminal node 2. And then next one, we need 2 terminal ups. Terminal nodes. Then I will show you again. And for this one, after this point, there are 2 kind of chance. So we need to decide which one. So after this point, we need another decision point. And then this one will be terminal. So looks like this. So after this alternative, strong and weak growth chance, but this point, we should decide which one we take. So decision point, we need 1 decision point and 1 terminal. So go back to the program. So on this node, right button, we need 1 decision and then 1 terminal. And then this one, we need 2 terminal. this. So now we are kind of preparing is done. So it looks like this one. And then we need give them value like this based on them. So it's like revenue is if choose this one alternative and then in strong growth condition, revenue will be $195,000 next 5 years. But cost to move new location, cost is 210,000. So this one minus this one is $765,000 value. If take this one, and then this one the same, because economic condition is not very good. So less revenue next 5 years, and then cost to move to new location. So this one minus this one, it will be this value, and the same calculation, and so on. So based on this final value, and then their name. Okay, go back to the program. And for I'm not sure this one work or not. See. It doesn't work. How can I bring this one? Okay. Reference. Bring this one here. Okay. So we need a name here. Oops, it's gone. Okay. Maybe I can share this one to show. Okay, got it. So click this one, click this node, then ask label and so on. So this label, strong, no. Move, no, store to new location. So I will just type new. Like this. So move to new location, alternative. And then the first one, this one, strong. Maybe gross. Then we don't know pay up. Yeah, pay up is this one, 765,000. And second note, probability is, it says no, strong growth is no 55%. So 0.55. And next one, weak growth. And then pay up, that is 365,000. Chance is 0.45 because this one's chance is 0.55, so 1 minus 0.55 is corresponding to 0.45. So we got this. And the next alternative label is expand. Expand the store. Just yeah. Then this label strong was, and pay up is 863,000, and probability is 55.55. And next label, weak was. Then pay up value is 413,000, and probability is 0.45. Done. And next one, because here there is no decision point, so just yeah, label first, do nothing. And label strong was, but we don't know pay up value because after this point there is decision point, so pay up value is just blank. Or and then probability is 0.55, and next weak growth. And then pay up value is 0. Pay up value is 525. 525,000. This one. Then here, after this point, expand or do not expand. So first node, label, we don't need the label, just expand next to here, and then pay up value is now 843,000, and next One is do not and payoff value will be 850,000. Done. Something here. Just type 0. And done. Are you done?
Yep.
Do you have the same result like this?
Can you go back to where you just went back and said to put in a 0?
Here, yeah.
Yeah. So where?
I did make it blank. Then if make it blank, then it doesn't work. So type 0.
Okay.
Then here, layout. If you click layout, then using this horizontal margin from this side, and then vertical margin, and then node size, bigger, smaller, like this. So you can change like this to big. So that is okay. And then edge. So this one you need more kind of acute. And change it like this, and then scale. Wow. This one okay, and then width longer. So if you type long name, then you make longer like this. And this one is look better. And then height like this. This one is about, this is better. And then from this we done, then you can see the line black, 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 here green, like this. So based on this decision tree, on this decision point, because this one is higher than this one, so take this one. And then based on the percentage, so take the 850, go there, so 850 times 0.55, and 525 times 0.5. So expected value is $3,750. Among three expected value, this one is the highest. So take this one. So decision is do nothing. But after 1 year, strong growth, still do not expand. So in this nature, with a kind of risk decision making, do nothing is the final decision. Okay? What do you think? Doable? So, I'm sorry again. You have another assignment. So looks like this. Looks like this. And then I show you how many alternatives and then how you draw decision tree. So you need the 3 alternatives, and then each alternative has 2 options based on the probability. Then you need hands-in. Oops, I didn't show you a right one, right? I should show you again. I didn't share a right one. Okay, just a moment. Simon, Marjorie. So looks like this. There are 3 alternatives. So there are 3 alternative nodes. Each node needs 2 conditions: favorable, unfavorable. Chance is 0.4, 0.6. So after draw the decision tree on that website, how can you make the file? Here, PDF. So click this PDF. Then this one asks where this file save. So in this case, mine is, this is an example. So module B, example, answer. I made this one already, so 1 and save. Then find that file, PDF file, and then upload. Okay? It will be fun. It will be fun. So just make you experience how to draw this decision tree. If we use Excel, similar, but we need some calculation and then type function and so on. So this using this silver decision website is convenient. Okay. Okay, now 7. So take a 10-minute break. And then I will be back 7:10, and then next chapter, one more chapter. Okay. Okay, see you in 10 minutes. I'm back. Next chapter is linear programming. Earlier we did assignment method and part of the transportation method. They are kind of linear programming. If a company produce multiple products, then maybe about the cost, maybe about the profit. Then how combine those multiple products to maximize profit or minimize cost in given constraint, limit resource such as limit resource. To find an optimal solution, we can use this linear programming. So linear programming, if we like rich people, they have money, so they can buy anything. But like an ordinary people, limited budget, in a limited budget, when we buy something, then we think how many this, how many this, how many this, like that. You know, this time because of the pandemic situation, we don't go many times to a grocery store, but in regular time, usually I don't go that like Walmart and the grocery store on Friday, and I don't go on Friday because not every Friday, but it's like every other Friday. It's like a payday, and some people buy it like in 2 weeks in the grocery, and they pay in cash. I saw so many times. They don't know how much that they buy, but then when they scan, then it's over their budget. So I don't want that. I don't want that. So because of that person, long waiting line. So because of limited budget or resource, we should decide which how many this one, how many this one, how many this one. So the nature, because of limited supply, so we need this linear programming. So linear programming, LP, refers to several related mathematical techniques used to allocate limited resources, usually scarce resource, limited resource. And then kind of an essential condition to use linear programming. So first, I mentioned already, limited resource. If it is not limit, we don't have limit, unlimited, then we don't care about how many this, how many this. So first condition is limited resource, then we use linear programming. And then objective, minimize something, maximize something. linear programming, we call this single objective model. So only one criterion, minimize cost, minimize profit. So using only one objective. So we call this linear programming as a single objective model. But if there are multiple objects, like objectives like maximize the profit and minimize cost. So if we have multiple objectives, then another method, goal programming. So that is not multiple objective model. Goal programming is not multiple objective model. And then linearity, you know, this one is y equals, if the function is y equals 2x, then it's a straight line. But the exponent of x variable, 2 or higher, then it's curve. So if it is the variable's exponent is 1, then we can use this linear programming. If exponent of x variable is 2 or higher, then that is curve. Then we use non-linear programming. And then homogeneity. It's like that. Similar condition to this one is in a straight line. Then the cost for buy 1, 2, 3, the unit cost should be the same, but like a discount in price, more than 10,000, then discount in price like that, then it can be the curve. So we need this homogeneity condition for linear programming. And then divisibility. To use linear programming, we can divide, like half hour of labor, or 2/3, 3/4, something like that. If we can divide the unit, then we can use linear programming. But if we cannot divide, like a half person. So in case if we cannot divide the unit, then we should use integer programming. So using a whole number like 1, 2, 3, 4 like this. So they are 5 essential conditions to use linear programming. Something like this. So 5 condition satisfied, and linear programming. If multiple goals, then multiple objectives, then using goal program. If it is not linear, then use non-linear programming. If it is not if we cannot divide, then use integer programming. And our linear programming model, we need a kind of formulation like this. Earlier, I show you briefly when we did an assignment method. So first, we need objective function. So it's like if it is a maximize problem, then max z. Minimize problem, then min z, and then equals. if it is like a profit problem, then type first type product profit, and second product profit, and so on. And then constraints, resource, limited resource, such as the labor hour limited, then such and so on. So using example, let's develop this formulation for the linear programming. Example, cycle trends is introducing two new lightweight bicycle frames. One is deluxe type, and then the other one is professional type. Then use aluminum and steel alloy. They are materials, resource. The anticipated unit profit are $10 for deluxe and $15 for the professional. The number of pounds of each alloy needed per frame is summarized on next slide. A supplier delivers 100 pounds of aluminum and 80 pounds of steel. So they are limited resource. Then how many deluxe and professional frame should cycle trend produce each week to make maximum profit? So first, by the way, to make a deluxe frame, 2 pounds of aluminum and 3 pounds of steel. Professional, 4 pounds and 2 pounds, like this. Then first step to formulate this linear programming is defining the objective. So profit maximize. So maximize total weekly profit is objective of this linear programming. So start with how many products. There are 2. So X1 and X2. X1 is the deluxe frame, the number of frames produced weekly, and X2, number of professional frames produced weekly. $10 profit, $15 profit. So objective function of this linear programming is max, because this one is a profit problem. So max Z. Z means like because this one is profit, so max profit. Z means profit equals, if this company produced the first one deluxe frame, then $10 profit, and professional $15 profit. Then write a 1 or 2 word description of each constraint, limited resource. There are 2 limited resources, the aluminum and the steel alloy. So aluminum available and steel available. Write the right hand side of each constraint. So 100 aluminum and 80 steel available, up to that many. So left side should less than or equal to right side value, like this. And then X1 deluxe frame and X2 professional frame use aluminum and steel, so X1 and X2. And then usage deluxe need 2 aluminum and 4 professional need 4 aluminum. So 2 and 4. And 3 and 2. Deluxe 3 steel, professional 2 steel. Done. Disregard this message because you will take the test. So this is even part of the linear programming. I just to show you how we can develop formulation for linear programming. And using this formulation, we can use Excel then solve. So I will show you. Where's Excel? Example file. On Moodle. Moodle. This one. So module B example, open this file. If you can do it together. So open this file. If you are ready, let me know.
I'm ready.
I'm ready.
Okay, good, thank you. So, like other assignment method and transportation method, we need this kind of tablet. So, we need profit table for $10 for profession deluxe, $15 for professional. And then this area, how many production? Like earlier, assignment method, assign one, something like that area. So how many? This area. So now it's blank. And then this one is this objective function that the max z here. So this one currently blank. And then constraint part, limited part, start from subject 2. So this part is an objective function part. And this part is limited resource part. From the this one, deluxe need 2 aluminum. Professional need 4 aluminum. And then deluxe need 3 steel. And professional need 2 steel. And then limited 100 and then 80. So prepare kind of table for the linear programming, running a linear programming. Looks like this. And then this part is like this. So 2 times x1 is this one, plus 4 times this one, less than this. So this part, click this cell, equals I think you remember the function sum product. So this part times this part time and sum of them. So for this equation, 2 times this one plus this one times this one. So using sum product, so type sum product, then we can see this function, so double click. So this area times comma, and then this area, and so I will show you sum product B5 to C5, B5 to C5 times comma B8 to C8. Now it's 0 because there is no value there. The next here, 3 times x1, 2 times x2, and then sum of. So this area times this area. So it's the same, equals sum product this area, comma, this area, enter. And then we need this part. This part is an objective function max z equals 10 times x1 plus 15 times x2. So by the way, this one is x1 and x2. So this area times this area, and then sum of. So the same function equals sum product this area 10 and 15 times x1, x2. We don't know yet, but so now we are ready to use solver. Are you ready? Okay, now go to data, and then as you know, solver, and then objective, set objective, this cell, the objective cell is this one. And then this one is maximize problem because it is no profit. And then changing area. We need x1 and x2. This area. And then constraints. Add this one and this one. This value should be less than 100. So this one, so add this one less than or equal to 100. You can type 100 or just click this cell one by one, or like earlier, this area less than or equal to this area. And click OK. Oops. And then we have this limited the constraints, and then make non-negative condition okay, and then simple x, using simple x, and then solve. Let me see. Okay, here the result is 15 and 17.5. Okay, one of the condition, divisibility. Uh, 0.5 professional bicycle frame. Not make sense, right? So I think we need one more. So this one cancel. The result we don't like. Then do it again. Server. Then still the same. Then one more condition here. Add. Then this one, I want this one, not a fraction. So we need this condition. If we want they are integer, so that case, just integer. And then okay. So we added the result integer, not 0.5 or something. And then solve. Now 14 and 18. Okay. So we will keep this result. Okay. Good. What do you think? Doable? Okay, sorry again. You have one more. This one, assignment 8, not 8, module B. I gave you formulation. This one, disregard, not disregard. You know, when we did this one, make unconstrained variable non-negative. So that means, this means this. So as long as this checked, this one is checked, then satisfy this condition. Okay, I will not give you Excel pre-table. It's kind of challenge. So based on this, think about it and then try. So based on this table, pre-table, try make it, okay? So if I give you a hint, then you know, okay, just a moment. For the example, there are only two constraints, but for 3, so you make one more constraint raw, but then x1 and x2 are the same. There are 2, and then just you know, constraint, just one. Let's say not one. A constraint, B constraint, C, and so on. Okay. So it's like A material, B material, and so on. So A, B, C. You need to know one more row, and then others are the same. Then change the number and so on. Okay. I think you can do, because you did assignment method and then the transportation method. Even I gave you a pre-table, but conceptually, I think you are equipped, and then I think you can do it. Question? If you don't have a question, then that's it for tonight. What I prepare for you. So, by the way, due is next Wednesday. All 3 assignments due is now next Wednesday. I think you can do it, and then you don't need much time. You don't need much time to do. Okay. In case you may watch again the recorded lecture, whatever you part you need, or ask me, then I will help you. Okay, that's it, and see you next Tuesday. We have only 1 week, and then done.
Thank you. Have a good
Thank
night.
you.
Thank
Good
you.
night.
Okay, good night.
Bye.
Good night.